Welcome, 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 welcome. It's Saturday and we're live. Yes, learning to program. So you want to learn to program, huh? A couple of interesting things, actually, from last week. Did you do your homework? Did you find a better way of doing it? Well, that's up to you. For me, I'm going to keep it. So I have all of this stuff here. Lovely. Right, refact input methods from window to input. Not a good idea, correct. Would you do that? No. Because our input relies on the window. That's one of the catch-22s with GLFW. When you're using something like a third-party library, you are restricted to how that library works. Normally, I'd write my own, or use something different to GLFW. Code smells, avoid void functions. Well, I've thought about it. I thought about it quite a bit over the week. If this was C++, then that stands. That is true. Even though in my C++ series at the moment I'm throwing voids all over the place. I'm doing it on purpose, but hey ho. Void functions. Let's talk about that first. What is a function? A function is a piece of code. This is a function here that does an operation. So in this case, it prints out to this console here some text. And that's the text there. So you can see what it does, type of thing. That's what it can print out as well. It can print out numbers as well. Yeah, that's a function. Is it a good function? It is actually, and that's the problem I've got with this code smell thing. I agree completely. Avoid void functions. But what would this return if it wasn't void? It would return a system error that it couldn't print the text out. And that's how you've got to think about it. All functions should return a value. Otherwise, why is it a function? I mean, in this case, it's obvious. I want to print lines out here, there, and everywhere, and I want to call it log to console instead of system out print line. Instead of typing that there, I just want to type that there. The two things are exact. All I'm doing is replacing a command with something in English that I can understand. And that's what this function is about more than anything. It doesn't actually produce anything. I think that's the best way of putting it. Functions that produce something. There's two types of functions. There is a function that produces something, or a function that has a side effect. And in this case, the side effect is that this text gets placed in this console. And that is a side effect of the function. It doesn't actually produce anything. And that is what you've got to keep in your mind when you're writing functions. It's very important that you keep that kind of idea foremost when developing. I think that's the best word for it. Developing, yes. Researching, R&Ding, whatever you want to call it. You can get rid of that for a minute. So, that's my take on those two. So I've argued my way out of them. As for this complicated way of handling time, does it do its job? My biggest worry about it is that line there. And it's the only thing I'm concerned about. You've got a render false. What happens if unprocessed time is greater than the frame time? Well, if it is, it jumps all the way down here to if render. And it doesn't render. Ah. Interesting. Else try thread sleep. Interesting. So frame time has to be as large as possible for it to work, and I think that's what this is relying on. So if we look at frame time a little bit closer, it equals 1 divided by the frame cap, and our frame cap is 5,000. So 1/5,000th unprocessed time. Now unprocessed time is a counter going upwards. So if it does go greater than frame time, it's going to stay greater than... I'm not sure about this at all. That worries me. That worries me a lot. But I'm going to keep it. I want to see if this works. I think it will. But not as intended. The intention is, when you're not rendering, you want to be updating. That's the point of this while loop. This while loop goes through the updating. Oh, wait a minute, let's render. Updating. Oh yeah, wait a minute, let's render. That's the cycle. The cycle says that whilst we're not rendering, we update and input as much as we can. Running equals false. That's wrong. That's just flat out wrong. That's stop. Okay. I don't think there's any return from stop, is there? No, it's a void again, so yeah, that's fine. Because that does running equals false. There we go. And it doesn't repeat itself, it'll just return out if it's, as you can see, if there are multiple entries for stopping, it doesn't matter, it just returns. There we go. So that's a nice feature that I hadn't used. I think that's the only place where I use it. And it works. So yeah, I'm not overly happy with the code, but I think it's a good basis for teaching, except the understanding of this. If you can understand this load of time gibberish, then that's all well and good. If you did think about refactoring it, how did you do it? You're going to tell me? Oh, let's say hello to you all. Hello, viewer. Ah, dear. There we go. Hello, viewer. I've chatted to you. Hiya. What I would do is I would transfer a lot of this processing into here. That's where I think it should all be. I don't think that this is doing what it can do. This could do a lot more of the work that game, main program is doing. And that's the point. So that's a theory over with. Transfer quite a lot of this over into time is all I'm just going to say. That's how I would refactor it. And then that will get rid of some of the ludicrousness of it, I think, like, where is it? Set delta time here. Wow. There you go. Right. What's today all about? Well, today is the next step after last week. Last week was all about how to show your beautiful code to the world, which is by formatting it in a nice, easy to read way, which I hope I've managed to do here. I also showed you how to write downwards rather than across, and that's going to be a big feature of today, because today we are going to do something interesting. We are going to do the next step, the step that everybody should learn, and not everybody does. A bit annoying, but if you're a beginner programmer, this is very important. This is probably the most important video you will ever watch, because we're going to do a test. So, under Java Engine, I'm going to have a new directory, module, directory. I'll have a directory, and I'll call it tests. Let's see if that works. Yeah, that's worked. Now, this IDE, IntelliJ, doesn't know that that's where I want my tests. So there's a little button somewhere up here, is there? Project structure. Let's click on that one and see what it does. Ah, here we go. Here we are, project. Modules. Libraries. Oh, it's modules, is it? Okay. Sources. Ah. This is it, is it? Tests. So if I click on you, and I click on mark directory as test source root, there we go, it turns green. That's pretty. So apply that. Okay. Now, I know I'm teaching people how to program here, but at the same time, I'm also, well, not developing, but writing a 3D engine. And what I want to look at today is the heart of a 3D engine. And what does that consist of? The heart of a 3D engine is maths. I'm sorry to say. I am not going to teach the maths. Let's have a look. That's K-H-A-N. There we go, Academy. Here we go, Khan Academy. What I would suggest you do is visit this place if you want to learn the maths. Courses, here we go. So, well, let's have a look. Vectors, matrices, linear algebra, I think is one of them. Trig is good, algebra is good. Physics, AP Physics, yeah. Computing. There we go. There's some good stuff here for computing. Let's see if there's anything else. I can't see, but if I find individual courses, I'll pop them up for next week. But yeah, Khan Academy will cover everything to do with vectors, matrices, and stuff like that. So, where do we go from here? I'm not going to show you how to test this a lot because that button does, well, that's a lie, this button doesn't do that. You should really test everything. If you're a new programmer, you should be testing everything, that all of these are correct, and that is 60 frames per second, and that is telling you the truth. If you're relying on my word that it's correct, oh, thank you. I'm proud. Thank you. But it might not be. Just put that edge of doubt in your mind. Let's have a new class. Let's call this class. What have they called it? Vector 2F. Okay. That's what we'll have then. If it's good enough for them, it's good enough for us. Vector 2F. Okay. So there is already a library, a maths library here with Vector 2F, and it's been imported for us because we used it. So what I'm going to do is I'm just going to create that. Okay. That looks good. Yeah, that looks good. 2F. Alright. What I'm also going to do at the same time is just nip through these. There it is. Get rid of you. That should give me a red mark. Yeah, red marks come up here. There we go, where the Vector 2F is being used. That's good. Time doesn't use it, does it? Nope. Main program, yeah, get rid of you. Okay. I'm trying to get errors. No errors. Oh, thanks. Input. Delete. How do you get rid of something in this? Ah, delete. Okay. That's alright. So that's deleted. We're not going to do it. It's all in the window. You can stay there. Game. I haven't checked. Nothing there. Good. That's good. I should really do some tests in there. But no. We won't. So let's go back to Vector 2F. On my notes it says Alt Enter. But what does that do? So class. Vector 2F. Alt Enter. There you go. Create test. Because I've set it up for this green thing here, this is where it will create the tests. So let's do that. JUnit 5. Okay. Ooh, we get different ones. Alright, JUnit 5 it is. Fix. Okay. Are there any other ones? Okay. It's going to be coming into libs in here. Okay. Here we go. JUnit 5. As you can see, I've never done it before. Superclass, blah, blah, blah. Set up at before, tear down at after. Generate test methods for. I've forgotten something. Alright. I've forgotten to set this up, haven't I? Yeah, I have. So what I'm going to do is I'm going to set the class up, but without doing anything, if you can understand what I mean. This class is a vector2f, so it's going to have a private, and I'm not going to do what I normally do. Because normally I would put float and then m underscore something. I'm not going to do that on purpose. X. Because it doesn't look good when you use it later. And that's going to be a y. So there's my two floats. So vector2 is going to have an x and it's going to have a y. Now what I can do here is generate getters and setters. I'll have it for both, please. Okay. There we go. So all of this is pre-generated, note. This is not us doing anything. So we'll mark that off to about there. Yeah, that's about right. And all of a sudden we've got this vector2f with functionality, which we haven't made. All we did was type in a couple of things. Now I want to start this. So, oh, it doesn't do it that way, does it? What is this Control Alt Enter thingy? It seems to be a standard thing that they have in IntelliJ. A way of doing things. Okay, Alt Enter. Oh, right, that didn't work. There we go, create test. Click on that. Everything's okay. Here we go. That's what I was expecting to see, and I didn't see before. So, generate test methods for show inherited methods. Good, there aren't any. We'll tickle you lot and see what it does. There we go. Right, so it gives us 4 tests to start off with because we have not made these. And that's a good thing. You can ignore these if you wish. You don't have to do these. But I would if I were you. This is how you can learn to program what I call the easy way. Does it come off a right click on here? Yeah, it does. Split. There we go. As you can see, it's here now in test. I want to see what they've done here. Alright, okay. Yeah, okay, that's good. Yeah, that's good. So on the left, hello there, Jarnite. You've joined me today on my learning to program thing. And today we are covering tests, of all things. The dreaded thing that everybody says, oh, do you have to? No, you don't, but it's a damn good way of learning. So here's our tests. Alright, so our tests, I'm just trying to think how to get this to work properly. So if I run that now, what am I going to get? You just run it from here, can't you? Yeah, run test. Building. Building. It's good to see you again, John. Well done. Shout out to you, mate. Here we go. 2F in class com blah 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 cannot be applied to given types. Required no arguments. Found float. Reason actual and formal argument lists differ in length. That's nice. So we now have errors, which is what I wanted. If you don't get errors, then it's pretty useless doing it. We got now our thingy here. Got a refresh button. A build. Oh, we've got a build. Oh, that's what we're on. Messages. No messages. Okay. So now, what we should really do is create something. And that would be, you can create this inside, but if you do it inside, you're going to have to do it every single test. So what I'm going to do is I'm going to do this outside. So what I'm going to do is, there we go. I am going to ask it to create a vector. So vector, oops, don't do that. Vector to F, and I want not the JOML one, I want hours, which is the top one. Okay. I'm going to call it a victim because I think it's going to be a victim of slapping around the tests. And I'm going to just say I want it to be, what should we pick? 1.0f, comma 2.0f. Okay. Now already we've got a problem. We can't do that. Is that coming up in window? Oh, it is, isn't it? Oh, that's good. That's even better. We've got it in here, so we're going to have to make it work, aren't we? That's even better. Wow. So if I Alt-Control that vector 2F there, what do I do? Oh, create constructor. Oh, can you do that? Yay. I don't know. Where are we here? So, Alt doesn't do anything. Make sure that's highlighted. Alt Enter. Create subclass. Make blah 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 private. Yeah, that's not very good. I'll write it anyway. Okay, so we've got our tests. We can't run them because they're going to automatically crash the system. So let's write vector2f. We'll make it public. And we're going to call it vector2f, of course. You can get this to be done automatic, I know, but float x, comma, float y. This now causes a thought to occur. Hold on a minute, we've now got two variables and they've got the same names. How do we differentiate? What we do is we ask this dot x to to be equal to x. As you can see, these go purple to identify them very handily in this editor. I don't know what your editor will do, but good luck with it. This dot y equals y. So very simple standard constructor. And that should work. Okay. Now what's window Java doing here? There we go. It's still not happy about something here. Oh yes. That's wrong now, isn't it? Yes, it is. Wow. Yeah, it isn't .x. I made them, if you have a look back, it isn't .x anymore because they're private. We've now got getters and setters, so we have to use the getters and setters. So it's changed our program already. So that will now be get x and get y. Alright, so that should now work. There's no other red marks? No. Can we compile? Legal start of type. Oh, of course it is. That's C++. Whoops. So, over here, vector2f victim equals a new vector2f like that. Is that correct now? Yes, should be. Build that. Make sure we can build. Yes, we can. We're in a good place now. So let's run our tests. Okay, they all pass. Why do they all pass? Because they don't do anything. I can't believe that we ask for getters and setters and it says void getX. Shouldn't that be float getX? Unbelievable. So what we need to do now is the X component on vector2 Java. So here we are. It's float void getX is the test. So let's do the test. Let's make sure it works. So what I'm going to do is assert. Oh God, how many asserts have we got? Okay, assert. Let's try true, false. What do we got? True equals. Float expected. Yeah. Okay. That's array equals. Wow, these are huge. Not equals. Anything else down here? Ah, here we go. Oh wow, this is awesome. Wow, this has tons. Equals. Something equals something. So I will put in. Can I see the screen, please? I don't want to see that. Thank you. We're on getX, aren't we? So victim dot get x is equal to 1.0. Actually, I'm going to put 0.0f. Okay. Now, run test. There we go. That comes up. Good. Assertion failed error. Expected 1, actual 0. Click to see difference. This is how we generate tests. We use asserts to make sure that the functions that we are writing give us the correct values. And that's the whole point to this. So actual expected equals 1. And that's not what it got. So you look at this and go, oh, yes, that's correct. So I'll just run that test again. As you can see, red dots come up now, all over the place. Your tests aren't working. Run that test again. Process finished with Xcode 0, test green, and it's okay. You can see this, can't you? Yeah, that's working all right, yeah. I'm just looking at my video preview. I'm doing this slightly differently today, in a quieter environment. The environments have been too loud for me lately. That's lovely. Black, fizzy, burpy liquid. Alright, so we've now got our wonderful tests. You can see roughly how they are going to work. And what I am going to do here, each test is separate, by the way. Absolutely separate. So what I am going to do here is I am going to get our victim. And I'm going to dot set x. And I'm going to put a float in there. So I'm going to set it to 99.9 f. Okay. So now we can, and this will make more sense now, assert equals int expected. Oh, I can press return on that. Good. And it's going to be victim dot. We know the getX works. GetX is whatever we typed in, 99.9 f. Okay, now it makes more sense to it. I'm hoping how tests can build. So let's run our tests, and if it works, can't run all tests, can I? Can I just assert false on these? Yes, I can. And do I need to put it in? Yeah, that's okay. Right, these ones that I haven't done. I don't want them coming up as passing. And that's no good to us. Right, so up at the top we have run. We have here, I think that's a run test. Shift F10 will do it. So let's press Shift F10. Let's try that one. Shift F10. Okay. doesn't seem to have done all of them. That's interesting. Alright, does that one? Yes, that does. And it still ticks them. Alright. Got to get these correct. You need to get false. Come on, run my set of tests. Oh yes, that's better. Fantastic. So there we go. We now need to write the tests, obviously. We've got getX and setX now complete. The next one is getY, and we can assert that it equals 2. That's what we think it should be. So we will do a replacement for this. Well, actually, I'll do it properly. Come on, just get rid of it. Come on, come on, come on, come on. So it's assert equals, and we're going to get victim dot, is it get y now we're doing? I can't tell because there's a helpful screen in the way. And it should be 2.0 f. What happens if you reverse the top 2 tests here? Will they still work? And the answer is yes. Of course they will, because these are separate. These are encapsulated tests, and that's why you use like JUnit 5 to do your tests, because they are all encapsulated within themselves. They are sharing victim between the two of them, but each time a test starts, victim is reset. That's very handy to know. Very handy to know. Will save you a lot of time. So yeah, this is looking okay, and it's already been written for us. We shouldn't have anything in here. So let's see, is it false? Yeah. I'll do the last one. No, only do one test at a time. Make sure they pass. Let's see what happens if I click that green button there. Oh, that does all of them. Oh, that's good. There's another green button here. Return failed tests. So if you have a lot of tests, there you go. That will tell you which ones have failed. That button there. That's good, because you might have like 1,000 tests. So set Y needs to be done now. You're probably thinking, what you would really... I've even missed a test here. I've actually missed one completely. And that is the test that the constructor works. And you should have a test for that. I'll do that in a second though. So, assert equals, and it's victim, yeah, victim dot set Y. And we are going to set it to, this isn't an assert, we are going to set Y 50.54, that'll do, F. Okay, and then assert. But blades, what is the point of all of this? What does this prove? It proves that your program works. And there is, I'm gonna talk more about this as we get deeper into it. And as we get deeper into it, you'll see why it works. What we're doing now. Victim dot get y, and that should now be 50.54f. Okay. We can now run all the tests, because it's got a little red marker by it. I will run all tests, actually. See how quick it is. Yeah, it's just run that test because I'm inside it. That's fine. That's good. So if I'm outside it, it'll run all tests. No. Have I still got that clicked on or something? Okay. I think this is the only one that I trust. What's this say? That's better. Oh, excellent. It does split them up like that. Oh, that's fantastic. Now, you might say, but the constructor, why would you test that? Indeed. So what I would do now is I will do an alt insert, generate a test method. There we go. The name of the test method I'm going to call constructor. Yeah, I'll call it constructor. Constructor. And how are we going to test this? We are going to put in vector 2f. I'm going to call it first. You don't have to use victim. Equals a new. Actually, is it work? Yeah, I could just use victim, couldn't I? I'll use victim. Stuff it. Just use victim above because that's the constructor. That uses a constructor there. That's how you construct a victim. So what we need to do is equals. Okay, let's, yeah, set equals. Set equals, and it will be victim dot get x comma, what have we put it to, 1.0f, and assert equals. Now you're not supposed to do it this way around, you're supposed to do your tests first and then you code, but anyhow, that's just the way it's worked out today. Victim dot get y. That was a bad one. Have I just turned my caps lock on? Yeah, I did. Comma 2.0f. There we go. Get rid of that. I think I have to be outside for it to work. There we go. Constructors come up correct. So top left, constructors okay. So we know our constructor works. We know all of the functions that we have in here work. So now that we have tests, if some other person comes into this file and alters anything, I can go to this file here and click that button, and it'll tell me if they've wrecked my code. And if they have, I can correct it and shout at them nastily and say, stop wrecking my code. Right, let's do some functionality now, because we've done the getters and setters, and the getters and setters are obviously easy. So that's all our getters and setters done. I haven't put that through. Can you go here, please? There is a very, very faint line between them. Also tells me where things are, so it's here. Okay, so I just use Alt Insert, I guess. What's the first thing we should write then? We'll have a test method, and we are going to write vector length. Length. Okay. And this test is how to calculate the length of a vector. Now, you don't need to know any maths. It's all right, people. Don't worry. This is probably going to be quite simple, really. How does it work? Well, we want to calculate the length of our victim. I've chosen bad numbers, haven't I? Alright. So I'll do this differently. Because we know the constructor works at this point. So I don't like tests that depend on other tests. But I still... No, that's what I've set myself. That's what I'm going to have. Yeah. Alright. Sorry, I'm just trying to decide how to do this. It's going to make it sensible to yourselves. So, over here. We're looking at our first function, aren't we? Now you can see why I say write down the screen, even though I haven't here. Mind you, they're only simple asserts, aren't they? Alright. Our first function is going to be a public float. And it's going to be called length. Okay. And it's got to return a value, otherwise we can't do anything. And it's going to return 0.0f. There you go. I've written the function and that will work. If I compile, that will work. Watch. Compile. There you go, it works. But does it actually do a vector length? Let's find out. Let's do a vector length that I know. So we are going to call this, not victim now, we'll call it first. Vector 2f, we'll call first, equals a new vector 2f, and it's going to be 4 point. No, it's not. It's going to be 3, isn't it? 3.0f, comma 4.0f, which are quite high, and well, they are tidy numbers. Okay. So if we now do float result equals first dot length, what result should we get? So assert equals, and the answer is result. So let's calculate it out, a bit of maths, blah de blah de blah, 5.0 f. I know that's the result for a 3, 4, 5 triangle. So that's our length. Okay, run tests. It's inside vector length, so it should only do that one, I hope. Oh no, it's doing a lot, that's good. So we have a failure. Here it is. Expected value and actual value. Oops, I've got those the wrong way around. Interesting. I could put that into there. What I am thinking is, instead of doing that, so I know the actual answer. That's the wrong way round. Try result. That way round. I've done all these the wrong way round, haven't I? God damn it. I really do apologise. It's the first time I've used this. Yeah, it'll return 0, 0, that's correct. It's the first time I've used this system. 50.54. So that's, it doesn't matter which way to be. Yeah, I know. It doesn't read right. And that's 2.0 f. I'm not sure I should be hard coding, you see. I don't think I should. That's what I was actually thinking about there, rather than anything else. Because I'm actually putting a value in. It's a simplistic way of testing though, and I just want to get through testing and show people what things are. Okay. And I like my tests to be correct. Because I'm going to be relying on these in a bit. Trust me. When you see some of the things that we're going to be doing, we are going to be heavily relying on this. This is going to be the heart of a 3D engine. And if anything is wrong at all, slightly wrong, our 3D engine just falls to pieces. Teaching. And learning at the same time. Best way to teach is to learn. I've already just learned something important. So, now I run my tests. Synapse TV, sorry I didn't give you a shout out there. Hiya, hi mate. Good to see somebody new in here. Oh, I've missed a bracket. You're right, I have. Do apologise. set Y didn't work. There you go. That's what I wanted to get. No, so it doesn't matter which way around you put them. Let's have a look at that a little bit more, shall we? We have an assertion failure on set Y, and this is what I was hoping for. We have an expected value of 50.54, and the victim.getY doesn't equal that. Now, this brings up the biggest problem with 3D engines, and why people say, oh, they've released this AAA game and it's got all these bugs in it. That's why, because of what's on screen right now. How can you fall through the floor? Can you remember the AAA games where you buy them and on the first day you're running around this world and all of a sudden you fall through the floor? It's because they didn't run this test. And they didn't run this test because, oh, it's only a simple function. How can that go wrong? Well, it's just gone wrong. So that's wrong, and that's wrong. I'm going to leave that wrong for a minute whilst continue on my vector length. So, vector length. Yeah, that's okay. I was just thinking about putting first dot length in there. Cutting out the middleman. Expected 5. Got 0. Yeah. I mean, as a programmer, you can play around with this. Some people, I'll be honest, even me, I prefer the long way round. Is it faster to do this? Yes. It is, if you do that. It is actually. 5. Synapse. The expected, it says here, expected 5.0 F. I don't know, is it too small on screen, or do you want me to enlarge this window? Yes, that's right, it's hard set to 0, because we haven't written the function yet. You have to return something or it won't compile. And it has to compile for us to be able to do the tests. Let's see if that works. So I'm just going to do that. Okay. Does it just say the same? Actual, yes. Good. Set Y is still arguing with us. Good. Okay. So that's good. We've got the first thing you want to do with your test is get a negative result. You have to have a negative before you get a positive. If you don't know that your tests have worked. As we found before, I wrote out all of the answers to all the settings and gettings, and one of them has now come up as, ooh, that's tricky. Vector length, vector length, vector length. How do we do vector length anyway? It's a formula, isn't it? It's Pythagoras. So let's try a formula instead of returning a hard-coded 0, 0. It's a float. You're wondering, why am I casting to a float? That's casting to a float, by the way. It means that I'm going to be working in double floats because of this. Java language, or org.jml. I'll have... Ooh. Oh, they've got a util. Oh, gosh. I want to have a look at that. Yeah, Java language will do. I guess. We'll soon find out. Does that just put Java language in? No, finish it. .sq. So yeah, square root. Double A. There you go. These maths libraries use doubles, so I've got to make it into a float, which is half a double, so I can return it as a float. That's interesting. And what we're going to square root? How's about x times x plus y times y? That looks like a good equation to use out of the Pythagoras book of many working things. Would that work? Yeah, that'll work. Yeah, I'm happy with that. I'm not going to test it even more because I'll probably break it. So let's go back to set y. What's happened? The biggest nightmare in my life has just happened. What do we do about it if it's not equals? Is there a fuzzy equals? Assert. Is there a float? No. There's no fuzzy either. No, I can't do that. That wouldn't be a good idea. It's a 3D maths library that I'm creating. 2 decimal places is not enough accuracy. It will break your engine. Do we have a float? Well, it says we do. And it says we've got 4 types. Why have we got 4? I can, but then what would I place on the left-hand side, which is a function? I'm sorry, I'm being asked. I should read these out. Can you, Synapse TV, can you check if it contains 50.54? The answer is yes. But that's cheating. That's the function that we've written. I can't check if it contains 50.54 because that would go into the function and that would make it a useless function. So that code would then only work for that value. That's not any good to me. I need it for every value of y, not just one. Sorry, I've come over here again, haven't I? Alright, let's go back to these. See if any of these work. Control down and control up. Move caret down and up. Yeah, okay, thanks. Excluding different organizations. Okay. Let's try that one. Then let's try 50.54, comma, and what have we got? Can you get out of the way? Victim dot get y. Now this is going to be interesting if I got my theory right. This is the kind of thing that I have to deal with as a research and developer. I'm the person that's got to pick or find gaps. That is a gap at the moment. Let's try it with the second one. You should do exactly the same. Oh no. So we have a set y that doesn't work. Now, how did I do this last time? I used a fuzzy logic thingy. I'm just wondering if I've actually got it in my test notes. Because I've got is equals to all over the place here. Oh, oogles. I just remembered it. Remembered it. Right, so it's our test that is not quite correct. We are going to have to decide now on a setting, and Synapse TV got it right nearly. In fact, nearly got it totally right. She said, you have to make it cut off after 2 decimal places. That's a very good idea. Let's see, 1, 2, 3, 4, 5, 6. Beautiful, there it is. So the accuracy here is 6 decimal places. Well, I know that that happens to be a float, and that the actual value we're getting here is a double. Or a 64-bit float. I bet that's a 64-bit float. No, my goddamn luck. It is returning a float. Everything says float, but yet we're getting that. Okay. So what we now have to do, assert true. Right, let's see if... Okay. G, no. True, yes. Aha, throws. Timeout. Wow, I like these. I want that one. So we're going to have to use assert true, because assert equals is not going to work. So... Can you get that thing out of my way? Assert that int of... This is victim get y, isn't it? Victim dot get y. That's got to be brackets. What I'm going to do is I'm going to cast it to an int for a true. Okay, which will give us 54. But I want 6 decimal places. So that's 1, 1, 2, 3, 4, 5, 6. And that has to be equal to... Let's come outside. Get back there. Int in brackets, of course. I do struggle with Java a little bit, because my thinking is in C++ and I'm trying to convert to Java. I translate in expected value 50.54 times 1, 1, 2, 3, 4, 5, 6. Now, is that true? So I'm asserting that the float is equal now. rather than a double. In my world, a floaty's only got 6 decimal places, so I wasn't expecting this to come up, and I'm not sure it should come up either. I think there's something wrong here, but let's see. There we go, it works. It doesn't actually show the results, which I don't understand. How do I show the results of all tests? Yeah, you can use true and false for testing, which means that you can type in something to test for, which is outside of, limits the test. I call that a test limiter. Now, the fact that it hasn't done it on all the rest, and it's only done it on set Y and get Y, I'm a little bit worried. So, set float, set Y, float, this Y equals Y. Absolutely. There's nothing here that says it's going to happen, but this caught it. So this piece, this equation should really be used on all the others, but I'm not going to, because I want these to break first. Never alter a test just because another test broke. Don't alter any of these, ever. Just keep them as they are. You think they're going to break at some point? I hope they're going to break at some point, because you're going to be doing a lot of testing, and all of a sudden one will break, and it won't be set Y. Okay, so our length now works. I put a mass equation in that I found on the internet. I googled how to get the length of a vector 2. It said this is the equation. I copy and paste it in. I click on my green button. There it all works. Lovely. Right, let's go on with the next one. What I'm also going to ask you is, when you are developing something like a 3D engine where the maths is crucial, would you use an exterior or an external maths library like JOML, which is quite valid? It has vector 2f in it. It's got all bits and pieces in there. The maths library here has utilities and stuff. Would you use theirs, or would you write your own? That's the biggest question I always think about. And my answer is, write your own. Make sure everything does what it's supposed to. If you rely on somebody else's library in your 3D engine, you get to a point where you are writing for that library rather than writing with that library. And it becomes tricky at that point to separate what you're doing and how you can experiment and how you can develop your program to a better standard without going in and changing the stuff that they've written. And anybody who's ever used an external library has come to that point, especially in making things like 3D engines or even 2D engines. I mean, this is 2D that I'm doing here. Why not? 2D's fun. It's again a thing that you might want to think about. I mean, these things. This is what I've picked up over years and years and years of experience, rather than, in the last 5 months doing anything. I mean, I've never used this test unit before, but I can test using it because I know how to do it. It's simple. I'm only doing simple tests, though. I'm not doing, the ultimate tests, which you probably should do. I'm only doing small ones. Right, let's do the next one, shall we? It's alt insert, is it? I'm getting used to this now. Yeah, test method. What name should we have for this one? Vector underscore dot underscore product. Do I need anything in the brackets? Yes, you're dotting two vectors together. So I will need a vector to f, which we are going to call right. That's the right hand side. Yep, that'll do for that. But if you notice, with vector length test looks nothing like vector length the solution. Make sure of that. Make sure you never have that piece of code in your test. It's got to test it some other way. That's another rule for this. So, how do we do a dot product? That's a good point, isn't it? Do I have one that's going to be easy? Well, one is easy. One left and one right is very easy. It's 2. I could use that one, couldn't I? That's victim. No, yeah, come on, we'll use victim. Why not? What do I need to set anything then? No, I don't need to do anything like that. I don't need length in here, do I? No. Right, so it's this. So I'm going to need a left. Yeah, I'll do it that way. Vector to f left equals a new vector. What value shall we give it? Let's give it easy values. I'm going to start with easy values because I've got to do this in my head. And let's get an answer from that. So what we need to do now is say left, and it will be dot. Oh, we haven't written it yet. Okay, we can't say that. So this is going to be public. Remember, you've got to get a negative before you can get a positive. So it's going to be dot vector to f right. That'll do. And it's going to return a value. 0.0f. I always start with 0.0f. It's a nice number. It's easy to recognise. There we go. Is that a valid function? Does it compile? Make sure it compiles. Yep. Yep, it compiles. So now I can write in my test left dot right and what does that give us? That gives us a float. So that gives us a float. This is going to be awful, isn't it? I don't think this is going to work. Alright, I'm going to use assert equals. And I'm going to give it a value of, I don't know. Can you stop? Yep, thank you. I want to see what the numbers are. So I'll do this in my head. So it's 1, 1 times 1 and 2 times 1. So it's 3. Uh, 3.0f, comma. So we expect 3. Am I correct? So left dot right should be 3. It's x times x plus y times y. Yeah. I think I should have put a 2 there. Oh, I wanted to show you this. Alright, let's do this. Let's just say you make up numbers. Passes. Oh no, we've got a mistake with me again. God. Oh, good. I put me 3 in, so it literally does. If you by accident did this, right, it doesn't work. Oh, thank God for that. Vector dot product vector 2f didn't work. Oh, you beaut. Wonder why. Oh, right. Internal calls made it fail. List for each, blah, 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 blah. Wow. It didn't like that one. Let's turn it into a 2. And let's put that as a 4. Alright, let's see if we can actually do this without crashing the program. Please. Doesn't look like we can. Ouch. It's not putting anything in here, is it? No. Okay. Thank God for that. Alright, so we've got a fail. A disastrous fail. A crash even. That's fantastic. Was it? Test failed 1, passed 6. Good. Alright, let's try and write a dot mate. How we would write a dot product. A dot product would be something like well, it's x times x plus y times y are the two vectors. That's the answer. You just look it up online. You can probably just copy and paste it straight in for a dot product. How important is a dot product? It's the most important thing we're going to write. This is the heartbeat of a 3D engine. This one function. So I better get this right. And my head's spinning. Stop it. Coca-Cola. Hey, Lynxy Cat, how's it going, mate? We're doing testing today. Well, I'm doing a bit of testing on a maths library. And I'm struggling, but it's working nicely. It's working out better than I thought. I thought this was just going to be a complete disaster. I was going to put it in the bin and just get on with the 3D engine. But it's working better than I expected. So yeah, good to see you, mate. Good to see you. We are writing a test that fails. And we are then hopefully writing the code to make the test pass. Because I know this should be correct. Pfft, as if. So for a dot product, we are going to use x plus x. Oh, x times x, is it? Yeah, x times x, isn't it? Yeah. So it's x times right dot get x plus y times right dot. Why does it keep? It's that underlining that keeps getting me. Don't do red on me all the time like that. Would that work? Do we think for a dot product? That's basically what it is. I mean, I could show you why it is that, but I don't think people are really that interested in maths. I am, but I don't think people who watch this are mathematicians. Oh, it still didn't work. Okay. It builds though. No parameter resolver registered for parameter. It's a float. Alright. Cut that, let's bring it out. And that would be a result. Right, I'll split it down. I'm supposed to put float results in there. Okay, does anybody know what the problem is? Array lists for each. The array lists are the vector2f's. Okay. Are we allowed to go through this bit by bit? Toggle auto test. Wow. God, there's tons of things you can do here. Import tests. Wow. I like this. I like this idea, you know. Has it gone to it? Yep. So what do I have here? Where's my step over? Debugger. That's interesting. I'm not sure how that's supposed to work. Aren't I supposed to be able to debug tests? I don't know. It's one of these weirdo things. Alright, so I've got a test that doesn't work. That's okay. Continue. La 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 la. This is what I was expecting to happen. My knowledge of the testing system isn't fantastic. I need to play with this more. And I think that's something I want to play with. That's how I would expect to write it. Oh, wait a minute. Wait a minute, it's a void. Wait a minute. I think I might have it. I think it's complaining about that. I don't think it uses the testing system in the way I thought it might. And this was supposed to be 1.0 f, comma 2.0 f. It should be the other way around, yeah. So 2 times 1 is 2. 1 times 2 is 2. Answer is 4. So it's 2 plus 2. Alright, let's try that. There we go, we pass. That is now correct. So did I need to put that in there? No, probably not. See, I'm testing the testing. Yeah, that's correct. So that is the correct test. Thank God for that. I'm getting the idea of this now. Let's do another one. We've now got dot products. Wow. We've nearly got a full 2D engine going here. With the two there that we've got, we can probably do most of a 2D game. And we've only done, what, a little bit? Wow. A little bit of typing. Let's do something difficult. Let's do alt insert. I like this alt insert business as well. It'll set up a method as well if you want it to, but I'm not overly keen on that idea. I do like to write my own, rather than all this auto stuff. I'm just old school, that's all it is. Well, I'm just old. Let's be honest. Oh, Linksy is still there. I had an ace idea last night. A really good idea last night. About a new series. I wanted to see if you were interested. Normalize the vector. Oh, right, good. It was all about, do you want me to have a go at starting like an encyclopedia thing, where I go through things I've never used before, like maybe mixing mono with electron, and looking into how these things work and how to use them. How somebody who knows nothing about these things would go ahead and use these things. What I was going to do is I was going to start with NPM and APM. I don't know if you know about this, Linksy Cat. Did you know there's an APM for the Atom editor? If you download the Atom editor and use that, if you're not on, I don't think you're on Windows, by the way you talk about your system, maybe APM might help. I haven't delved into it yet, but what I was thinking of doing is just like a series like The World of Programming, say, and start off with NPM, APM, editor, which I've never used. I want to start off with all the stuff I've never used, a bit like I'm doing here with this one, because then I know that I'm a noob at this as well. What did I do wrong? I put space in. That's what I did wrong. Shh, don't tell anybody. Yeah, that's what I'm thinking of doing, but as a series, and seeing if I can get things like these oddities to work together. Because mono and, well, Electron basically takes your web browser and puts it on the desktop in a window. Mono is a full .NET framework for networking and other stuff. Windows, Microsoft stuff. Let's get this up a minute. Better write our rubbish function, which shouldn't work. This is normalizing, is it? Yeah. So that's my idea. It's a total noob view into stuff and working out how to get it to work, type of thing. I'd love to do it because that kind of stuff really intrigues me. Experimentation and research is what I do as a job. So, you know, it's no skin off my nose to video me doing it. Basically, I'll be videoing me doing my own job, which is fine. Call it normalize. Now, what does normalize do? Does anybody know? We're going to normalize the vector. As you can see, I'm giving them proper names now. I put vector length, vector.product, and then I really should call it vector normal. No, I don't care. I don't care about the naming. I'm not going to do a naming convention. You can do. Name them all a certain way. But if I do that video series, you'll see how I put things together behind the scenes, especially when I'm doing things like this. Why have I got a red dot? Oh, it's got a return value? No, it hasn't. Whoops. Normalize is a vector 2f. Right, so we've got to have a return value. Return new vector 2f, because we need our test value, and of course it's going to be 0. So that's our return. That red mark should go away now. Yeah, that's our return value. Good. Right. So what happens with normalize? With normalize, you take a vector, let's say our eek. Just trying to think of a good vector for normalize. I have no idea. Oh my god, how are we going to do this? Alright. So it's going to be a vector. I mean, half the battle of this is making up the tests, and you've got to know the answers. When if you don't know the answers, then you can't write the function. And if you do just, you know, copy a function out and you think it's going to work okay, how do you know? And that's the problem that I have with a lot of people's programming when you're looking on YouTube. They have nothing like this happening. You know, they're not even attempting to validate anything that they're doing. But now I can turn around to you and say, look, I've got tests for these. They all work. This code works fine as it stands, but I would advise you modify this code and go forward with the tests and make it into, you know, better code, maybe. I don't know. So, result. The result this time is a vector. Equals a new vector 2f, and now I've got to pick some values, damn it. I'll have 3 and 4 again. And let's see if I can work it out. Okay. And I now have to assert equals, oops, I've got somebody's bracket here. Do you want it back? Yeah, I think you do. Nick somebody's bracket then. Assert equals. I always start with assert equals and then think of generating other things afterwards. And we need a value. Some value. I'll just stick 0.0 in there for a minute. It's wrong, but you know. And what we are going to do is result dot normalize. That one. Okay. Will that give a result? Yes, it will. It gives a new vector 2f. And puts it back into result. Yeah, this will work. It's going to be fun though, because now I've got to make a vector 2f. I don't know if this will work. Yeah. I'm going to have to work out these values now. Okay. What are these values going to be? We are normalizing 3 and 4. That makes the length 5. So the vector is going to be 3 over 5 and 4 over 5. 3/5 and 4/5. That is the correct. Wait a minute. I forgot to put 0f's on them. This is going to be interesting because how are we going to do this is going to be a really good one. Okay. All right. That's the correct answer. But can we do that? This is interesting because I'm not sure whether I can do that or not. Let's try it out. So, normalize, normalize, normalize. Doesn't take any input at all. It normalizes whatever vector you use. So really, I should just call it vector. And vector. No, it's this vector, isn't it? So it's left. Sorry. I'm trying to keep these in line. If you're wondering what left and right means by this stage, I'll show you. Any equation that you make has something like x plus y equals z, for instance, as an equation. The left-hand side is that, and the right-hand side is that between the two is an equal sign. So here, left and right is done this way. The left goes there and the right goes there, and the dot product is the equal sign. So it transfers the information from right to left. And that's how you should write your code. You can write it the other way around if you want. It is possible to do so. Might sound silly, but it is true. You can actually do that. Right, let's do this normalize function. How do we normalize something? This is going to look absolutely rubbish. Float length equals length. We've already got that, haven't we? Yes. Thank you. X. I'm going to do it in shorthand. Divide x divided by length. I'm doing it like this on purpose, because it's not understandable really. Yeah, we are a vector 2f. So this. Oh, not new though. Don't want to be new. I want to be this. Thank you. That's what I would write for normalization. All you do is you find the length and divide the x component and the y component by the length of the vector. And that's it really. And it makes a unit vector or normalized vector of size or length 1. Which is why I've got 3 over 5 and 4 over 5, because the length is 5 as we know. So I've got x and y over 5. So it really does line up with this, but as you can see, that equation is definitely looks nothing like that one. Here goes. Can we do that? Oh, what do we get? Assertion failed. Oh, that's interesting. I think we got the wrong thing. Okay. Okay. I've not seen this before. Yeah, just gives you that. That's dead helpful, but what is that? What is vector 2f at that address? Oh, something just came up. What's all this? Go away. Don't do that to me. It means that the two vectors do not match each other. We expected that vector and we got an actual... Oh, my test is wrong. Oh, I apologise. I really do apologise. That test is utter rubbish. You can't test like that. Wow. That... Yeah, you can't do it like this. That's rubbish. Assert equals, yeah, great. But 3.0 f divided by 5. I don't know that number off heart, so... And I'm not getting a calculator out. Is equal to dot get x. Yep. Right, I'll try that line first. See if I'm right. See if it'll compile and do something. Illegal start of expression. Okay. Doesn't like that. Uh, 3.0f divided by 5.0f. This is interesting. I'm liking this. I don't want to call it x. Result x, I think, is better. Result x with a big, big thingy. It can do the calculation for me. And because we're doing that, I'm not sure it likes that bit either. So what we'll call that then is... no. Just going to keep it for now. I want to see if this... I want to see if this will dot together properly or not. I don't think it will. I think that's... yeah, I think that's going to crash. Yeah, it did, didn't it? Good, yeah, it's that bit. Right. So cut you out. So that's the command WYOG testing. To normalize. And then all I should need to do is left get x. Should be that. What's with all these semicolons? I don't know. Try that. I'm not comparing vectors now. Ooh. Something weird happening. Something very weird is happening. Assert equals. Spelt it right, normalize. Yeah, I've spelt that right. This is normalize I'm doing, isn't it? Yes, normalize, thank you. Yeah, there's a debris floating around. I've just spotted a debris floating around. What do I do? Ooh, there it is. Compile. Okay, can I clear these? There we go. Everything now starts coming up with ticks. Thank you. But it does mean that we break the rules. And that's why I wrote it differently to start off with, because we want a result y. Can you get out of the way? Get off, go away. Stop it. I can't see what I'm doing. Oh, God. Left dot get y. Thank you. That's all I need to type in. And that's float result y equals whatever had 4 over 5, isn't it? 4.0 f over 5. You should rigorously test, by the way, not just do what I'm doing, which is simple test your libraries. Because without rigorous testing, are you totally certain? I mean, I'm still getting all ticks back, and I know that one of these tests is different to the others. So something's not fantastically right. But hey ho, I seem to have everything going nicely now. Excellent, vector dot product. Tick. Next. What should we do next? We've done normalize, haven't we? Let's do the hard one. Let's do rotate. Okay. I have no idea how I'm going to do this one. Alt insert. Let's find a way. So rotate. Vector. And that's going to be degrees, not radians. Right, okay. I'm beginning to like this test stuff, really am. Let's make something up over here that'll fail. Public. For rotating, we'll need a vector 2f to be returned again. So we'll have to split it as we did last time, I guess. Where's my f gone? Oh, I pressed control by accident. Whoops, f, thank you. Reason was I was trying to lift my hand up because the cat's clawing my leg. Yeah, the cat is clawing my leg. Oh my god. Rotate. Make itself a word. Rotate. Stop putting me off. And I'm going to have a float. Yeah, angle in degrees. Angle in degrees all day. Angle in degrees. I always put it like that. Let's do that. And it has to return a vector 2f, so it's return a new vector 2f 0.0. Lovely. That sets that up nice. Now I've got more experience with this malarkey. Let's see what we can do. It's a left one again, is it? And we've got okay, I don't actually think I can do a test for this. I've actually done one before for rotate. I've got addition, constructors, additions and subtractions, scalar multiplication. No. I might have one of the 3D though. Let's see if I've got any 3D tests. I've got matrix. I don't think that's going to help me much. Vector 3D, let's try that one. Addition, subtraction, multiplication, plus equals, minus equals, no, nothing in there. very simple testing that I've done in the past, just to make sure certain things are correct. Constructors, addition, subtraction, multiplication. No, I haven't. Okay. Fine. Alright, okay, let's write a test. Again, I want to pick numbers that I know will work. I have no idea what will work with this. Right, we are going to need the following. Float. Angle. Degrees. I'm going to put it in full. And we're going to put that equal to something. I'm going to just put that to 90.0 f for a second. What's to work all of this lot out. Does anybody know a good cos and sine number? The cos of 1, no, cos of 0. Cos of 1 is 0. So the sine of 1 is 1. Alright. R2 pi. Do we have pi? No, don't do that. Just leave that at 90 degrees for a minute. What else are we going to need? We are going to need actually, we don't need that at all. Sine 0 equals 0. Right, so cos 0 equals 1. Yeah. You can reverse them around by, is it 1 pi radians? I think so. I'm just going to put rad here. And 2 pi radians equals 360. So 180 for a pi radian. Pi over 2. That's it. Got it. Thank you. You got it, Linksy. Well done. So cos 0 is pi over 2. Better just put this in notes actually. Cos 0 equals pi over 2. Alrighty. And that means I can now work that out. And sine 1 equals the same thing, pi over 2. That's the values that I need to work with. So all I need to do is set a float to pi over 2. Possibly. Now, we are then... Oh, right, I've got it now nearly. I've nearly got it in my head. So what we're going to do is we are going to take a vector. Any vector. So let's take victim. Victim. We've already got victim. And all we're going to do is we are going to rotate them. Dot rotate. And it says float angle in degrees. Eek. It isn't 90 degrees, is it? It's about 40 something. I don't know what it is in degrees. Alright, rotate by 90. I am not sure about this at all. I think we might have to look it up. My God, I'm actually going to have to look something up for once. There's something. Because what we've got to do now, well, we've got to calculate it ourselves anyway, so... Sorry, go that way. Come on, Muppet, just go that way so you don't... Oh, alright, you still walk all over things. Cats, 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 cats. What we're going to have to do is exactly the same as what we've got here. So we're going to need to know float result x equals, I'll just put that for a minute. Float result y. Well, at least you can tell everything that I'm doing today is original. And then what we are going to do is we are going to assert equals, and it's going to be result x. Is the same as whatever victim becomes, victim get x. So victim get x. Okay, and I'll put small x instead of a large one. So now a plan is coming together already for doing this. Is equals, and that will be result y. Yeah, not equals, comma, and it's victim dot get y. Okay. And we need to know what those results are going to be. Interesting. All right. Yeah, unit vector rotate. Okay, what's that then? Right, yeah. Minus y, x. I thought it was a simple one for 90. I was right. Just pop you up here for a second. So... yeah. Okay. And that's minus y, x. I think we are going counterclockwise. So we should get -2, 1. Oh, yeah, -2, 1 for counterclockwise, yeah. We'll see if that works, I guess. I'll keep this lot in. Don't need you. For a sec. I think that's correct. That's what I've got off the internet, so let's find out. It should prove negative anyway, so it doesn't really matter, but does it compile? Alright, we're compiling. There we go. There you go. Expected -2 and actually got 1. How? Oh, because victim sets. Yes. Sorry, my bad. That is correct. That is fantastic. We expected -2 and actually we got the 1 from victim. So that 1 that we got was that there. That's good news. So our test is working. Wow. I've written a test that works. Wow. Sorry. Now, how are we going to damn well do it is the question. Just get rid of that. There you go. See, if you need anything, you just look it up on the internet. Honest. He says. So we are going to rotate. For rotation, I am going to do my rotation not in floats for starters. So double. The maths library is in double, so I'm going to use double. Stuff it. Rad equals math dot 2 radians, and just put angle in degrees, can't I? Yeah. Angle in degrees. There we go. That's easy. Double cos for cosine equals math dot cos rad. Right. This is what I think the answer is. I could be completely wrong. I know that the test is correct, which for once. I checked the test and the test was correct. It's great. It's good to do this because it's not something I would normally do. It's not my job to do this. This is what I'm trying to say. I'd like to do a video series on what my job is, rather than a video series on what I don't do. Like this stuff. But I can still teach it to people, I don't mind. You can watch me struggle and suffer. It's not the best way to show how to learn, struggle, suffer. Alright, as we've got so many tests now, I think I'm only going to run this one test. Alright, so we've got that far. What can we do with that? Well, we can return a new vector, alright. But it's not going to be x and y, is it? What should we do for x? Turn it into a float, because that's what we're returning, isn't it? A vector 2f is a float. Okay, so we've used doubles for the calculations. Yes, let's turn it into a float at the end of the calculation. So the first calculation is, just look it up on the internet, for a circle, a two-dimensional circle, the thing is x times cos minus y times sine of the angle. Okay. You then put a comma. Yeah, that's right. And the y is float. Let's put it back here, as it. I'm not happy about you putting it there, so. Open. It's not 0 anymore. It is x times sine plus y times cos. Now, is that correct? Now, how on earth do I know? I've just taken that off the internet. I've got no idea that's correct, except I know that for 90 degrees that result is correct. So that equation should produce that result. In theory. Let's find out. Just make sure I haven't forgotten anything. I have. And yes, I have there. So there's an extra doobry that I've forgotten. Okay. Let's try doing that again. Yeah, we're alright now. Helps if I get all my brackets and semicolons correctly done. Run rotation. Got -2. Actual is 1. Interesting. Expected -2, actual is 1. Have I done this right? Have we gone the right way round? Or have I really messed up my code? X times cos minus y times sine. 1 and 2. Okay, do we have a calculator online? Oh. I wonder who we're supposed to normalise for that. I might be wrong here. 2D vector. Rotate by 90 degrees. Is it supposed to be... I wonder if we're getting y minus x. We aren't, are we? It's not swapping around. Formula for rotating a vector in 2D. Alright. Cos x minus sine b. What have I put in? Cos x minus sine. That's correct. Then sine x cos y. Sine x cos y. The angle sum rule gives cos alpha plus beta equals cos alpha cos beta. Oh, that thing. Yeah. God damn it. So that's the equation that I typed in. Multiply the x part of the vector by -1. And then swap x and y values. That's what I was thinking. That is the simplest test that I know, and it's wrong. Multiply the x part of the vector by -1 and then swap them over. So if you were going clockwise, it would be -1, 2. So is this going clockwise or anti-clockwise? That's wrong. So the actual value that's bothering me, the actual value of 1, should never come out of that. Unless I got these two the wrong way around. Okay. We'll have to leave that as inconclusive, which you're allowed to do. Test doesn't work. Which means I've got to come back to it to find out why it doesn't work, and if there is something wrong with the test, or whether there's something wrong with the rotation equation, because I might have typed it in upside down, you know. There is that possibility. I mean, if we changed it around, would it work? Interesting. So if we put space between the two, cut, paste. I don't know why I just cut it, but never mind. Whoops. And what else have we got here? The cos minus y sign bit. Copy. This is why it's interesting to me, because it forces me to question. V. Okay. I'll do that. Okay, so the return values are now upside down. So I'll compile it. Make sure I didn't make a mess of that with copy and paste. Expected -2. Actual 1. So it doesn't matter which way up it goes. Really? I've got something wrong there. Never mind. So no, my instincts tell me the first one's correct. We'll see. Right, what's next? Got to keep writing code, can't stop. Otherwise we'll never get any code done. And I want a maths library. That's interesting. I like it when interesting things come up. That's the rotate one is the hardest one to get right. After that, it's all rubbish. Go on, we'll do this one. Let's have a go at... I'm only going to do one of these for now. And then and what I'll do is I'll do one, and basically after the first one you can fill the rest in yourself, they're obvious. So, void, alt, insert, test. This is going to be for add. I think. Am I thinking correctly? Yeah, I am. So, add. Underscore. Which one am I doing? Float or a vector? Add vector to vector. It's two separate ones. Done it again. And the other one I want is add. Now I've got to get this the right way round, because you can do it either way round here. Vector to float, isn't it? I want the float on the right hand side. Okay, so vector to float. These are simple tests, really. Well, supposedly. Let's see if we can write them. What do we expect to happen when we add two vectors together? We expect both x and y to be added individually, I believe. So we need to do an add function. So victim add something. So I'll need a right hand side. Okay, vector to f, right, vector to vector, we would send, oh, we don't do that, it's testing, isn't it? Right equals a new vector to f, and let's choose a couple of whizzy numbers, 21.0f, I don't know, comma, minus 33.33f. There you go, there's a nice vector. So I want to add a vector to a vector. So that will be, looking on my left hand side, we have nothing. So we better put something in. I think that might be a good idea. Let's make it a public vector to f, add, open, vector to f, right. public vector to f, and it's add, open brackets, float. Right. I think that's okay. Yeah, should be alright. So all we do after this is subtract, multiply and divide. It's all the same after we've done the first one. So that'll be the end of the test for today. These are the last two tests for today. That's a shame. How long have we been going? Oh, not bad actually, 2:36. First time testing. You get faster as you do it. It's practice. And it shows that I don't do it. Because it's not my job to. My job is to discover new ways of doing things. I might be having some fun with that equation. Yes. Maths is my favourite subject. So, that's the same. Copy. It's basically the same stuff on these two. Right is a float, though. So no, it's not the same. Forget that. I'm an idiot. Thank God for that. So, victim. What we're going to do to you today. Our victim is going to suffer addition. And it's going to be right. There we go. Vector 2f. That's it. Does that come out anywhere? Or do I just add it to it and use it straight? Is that where I went wrong here? Oh. Right. Vector 2f result equals victim dot rotate, and then all we do is put that, copy, can I just run that separately? No, that's not it. Ah. Oh, right, it hasn't compiled. My bad. My bad. Return something, please. A new. I should always check that it compiles first. Vector 2f 0.0f, comma 0.0f as a placeholder. Same again, please, Bob. Placeholders. There you go, placeholder. Thank you. Now will you? Yeah, okay, so I can click on it now. You skunk. You skunk. Doesn't say that in my notes. Doesn't say to make it equal to anything. Oh, I'm disappointed in that. Never mind. I was thinking I could put, you know, like .getx at the end of that and put it all in here. Oh. Maybe I'll work out a way of doing that. I think it's the way they pass the variables in Java is slightly different because it doesn't have pointers. per se, which it does have pointers. It just doesn't tell you that they are pointers, so you don't know which ones are pointers. It gets difficult for me to work with, especially on lines like that of code where which one should it be? Should it just be equals itself like this? Or should it be equals itself like this? When you add, I'm thinking there's going to have to be vector to f result. I'm thinking we're there, to be quite honest with you. Okay. That's left. It's on the left of the equal sign, it's left. Okay. So when we do that, we should have an expected, or a result x. So result x equals 1 plus 21, 22.0f. And that's a float. And get off me. Okay, thank you. It's hard to get your keyboard back. I don't know. Float result y equals minus 31 f, and we can assert those, can't we, as expected. Alright, assert equals, now it's starting to get easier. You see how it's now starting to get easier to know what the heck's going on and why we're doing things. So it's result x. You get into your own way of doing it, your own language. Equals, you'll have to get to the left dot get x, left get x, left dot get x. Ooh, missed it. And then again it's assert equals, and it's result y, and that's left dot get y. How many closes? Too many brackets that time. So why have I got extra brackets in here? Well, because I've typed them like a muppet. Now, that's what we expect. These should both now fail, please. Yeah, I'll write this test as well. No, I won't. I'll do the test one test at a time. Add vector to vector. That's this one here. So compile, make sure everything compiles. Okay, let's run the test. Expected 22. Actual was 0.0. So that's a failed test. That doesn't work. So now we have to write code to make it work. And let's see how we're going to do that. Add vector to vector. Alright, so it's still going to be a new vector, isn't it? So what we're going to have for the x? How's about something simple like x plus right dot get x? Oh, if telephone's going, that's a shame. And for our y, we can have y plus right Get y. Yep, I'm happy with that. Run our test. Still wrong. And we have it to 1, 2, 3, 4, 5, 6. So it is a float this time. So we've come up against that thing again, and we know that it was on another test here. So we can probably steal that test. There. Doing a search true type of thing. I'm just putting it here because I'm not allowed to copy and paste between these. But I'm allowed to use the same idea. So let's use the same idea. So that's not working very well. And again, I think it's on get y, isn't it? Yeah, get y isn't working very well again. Does anybody know why? The maths library that, or the functionality. Does anybody know why get y is failing? So, I know why, but that's nothing to do with it. Who cares about me? Does any of you know why? There are... oh, no, I was just waiting then to see if there was going to be a reply in chat. But nope, not reply. The answer is computers can't count. Can't do floating point maths to save their own life. They can do 1 and they can do 0. They can't really do much more. So the error is because the computer uses binary. Simple answer. And the people who make the maths chips and do floating point calculations or allow floating point calculations on their chips get it. Can't solve the problem of what you can see here. All of a sudden, this 2's arrived from nowhere. This has opened up a few exploits in the past where banks have had their extra little bits trimmed off and deposited into a Swiss bank account by the programmer. Yeah, of course, this has come from nowhere and doesn't exist, so nobody missed it. And they collected a lot of money. And then they were arrested and then they were put in jail and all the money had to be returned. Ah, but yeah, it was an interesting thing that they did. I would never advise them to do it because it's easy to trace and easy to track, and if you've got somebody like me who works for you, you start doing error checking like this. And you then suddenly say, hold on a minute, if this is true, then this program over here shouldn't be working the way it does. And then you're going to look at the program over there and, oh, so they're slicing off the decimal point there, are they? Yeah. What are they doing with it? Oh, they're storing it there. Where's that going? Oh, it's going into that account there. Oh dear. And then the police come and arrest you. So, assert true. We're using an int. We are using left get y. No, we're not. We're using result y. Thank you. Yeah, I should really do this with brackets. Result y. And we are going to multiply you by 1, 1, 2, 3, 4. If you can't have 6, you'll have to drop it to 4. And at this point, we have to start making comments. We are breaking the rules. And we expected to get int oh, come on. Thank you. No, that's wrong. And in this part, I want to put what we actually get, don't I? Which is left.getY. It's interesting that it's only happening on getY. So there is an error somewhere in the Java set, floating point error. How many brackets should I have? Oh, sorry. There's a condition. Yeah. Get Y. And again, that's times 1, 1, 2, 3, 4. So now you found something out about your maths library. Your maths library is only going to be accurate to 4 decimal places. Why is there an access modifier in front of the declaration? What are you talking about? You mean at test? These are tests. Yeah, this is testing. And I'm writing the code on the left. So on the right we've got tests. On the left we've got the code I'm writing. Oh, public. Why not? Tells me that I've written it in a public way. I can change that to private if I want it to be private, but I don't want more public. It's an old school way of doing things, I know. Half the things I do are done for... This is a learning course, a teaching course, so I've got to do it properly. I have to put public there, because that is how it's specified in the spec. That's the reason why it's there, because that's what it says to do. Yeah, that's okay. That might work now. Shall we see if this works? Just make sure I haven't messed up my stuff. Run the test. It works, but only to 4 decimal places. And we're going to have to go back up now and modify this last test. Because now we know that it's not accurate to 6. I want 4. Okay, put 4 there. And then when we get to the top, let's see now. Why didn't it automatically put the ending one in? I don't know. I've shown that the floating point calculations are accurate to 4 decimal places. NB, when used, be aware of the accuracy. Okay. Right, I'll put a warning at the top. Does it flag it up if I put it on a separate line? No, that's okay. Alrighty. So that's done. That's interesting. So as we've gone through these tests, we've actually found out things that we didn't know. Slow down, Seppi. This is Java, public Java. I thought you were coding CPP. Yes, during the weeks I do. Is this the IDE IntelliJ? Yes, it is. Is it for your students at Cambridge? Ah, not allowed to tell you. I'll get fired if I told you the truth. I do this to get this out to the world. How I do it, none of your business. The equipment I use is thousands of pounds worth of equipment to get this done. Right, on to the next one. We won't be needing that, I hope. Oh, we will, won't we? Oh, damn it. We'll see. We'll see if we need this silly assert true one as well. So... X, Y. Yeah. That is now correct. Yeah, okay. It's I'm wondering, with this accuracy, is it worth doing a 3D engine? We're now down to 4 decimal places of accuracy for a 3D engine. So, this is the last test, by the way, that I'm writing. I'll do that first, stuff it, and then we'll discuss whether I should carry on or move to a different language, because I don't think this is going to work. Okay. So, float, or adding a float. Yeah, why not? You're close to truth, Seppi. Close to truth. An engine in Java, why not? I will write an engine in BASIC if you want. Switching to white space. Yeah, I like what I'm doing. Until I can prove that this is an absolute waste of time, which I might be about to do, I'll just continue doing this. It's good teaching. It's teaching people how to write tests. It's teaching me what I've forgotten about writing tests as well. So, I mean, it's been such a long time. Over 30 years since I last wrote tests. So come on, give me a break here. That's why I'm using Java. No, it's not. Vector 2F, add a float. I wonder how we're going to do that. So, the expected results. Float right equals 25.4755 F. See if you can get this one right. So we want to add them together, do we? So float, no. It's vector, isn't it? Vector 2f. Result, is it, that we are using? No, left. Equals. Use B. Yeah. Cheers for that, Seppi. Oh, God, he always makes me laugh. You've put me off completely with that. Left equals victim. Oh, dear. Dot. Add. Float, which is right. And semicolon that. And then we've got to do the same as we've done above, haven't we? So float x. Float. Result x. Equals. We're adding, so that's 26.4755 f. Float y. God, I like the way I'm making it easy on myself here. Y equals 27.4755 f. Okay, now we've got to do the asserts. And I will start with equals every time. Whatever. Assert equals the condition. Eh, dear. Left. It's result, isn't it? Result. X. Comma. Left. Dot get x. So it's literally the same as what we've got above in the previous one, which is why I did them both together, really. Oh, I seem to have the right number of brackets for once. And assert equals result y is left dot get y, which will probably fail. Well, it's going to fail anyway, isn't it? So we won't know. Alright, so we're doing this one here. It should be a failure. Just going to build first. Okay, we're alright with that. A run. Oh, good. 26.4755 is the expected result, and the actual result is 0, which is correct. And how do we add these together? So let's fill these in. Vector to f will be x plus right. I didn't really need that, did I? And y plus right. That's the combination you want there. Yeah, that should do it. Yeah. I'm happy with that. Those have gone purple. Yep, that's right then. Okay, let's build. Can't see anything wrong with that. Okay, let's check. Now a test comes up. Oh, it passed. How interesting. I wonder if this problem's with negative numbers. Wasn't on the first one, was it? No. wasn't. Damn. If it was a negative numbers, I could have minimised the damage. But now we have a problem. And it's nothing to do with testing. Now we have a problem. Our tests results are in. And, well, are we happy with them? No. From what I have found out... Oh, did we get rotate to work? Yeah, we did. Didn't we? Damn. It's the hardest one to get going as well. So, if I hadn't have done this testing, I would know nothing about what I know now. Which is that Java, using this IDE and the stuff that they do, is only accurate to 4 decimal places. And I've now said, is that accurate enough? Please bear in mind that this is not just related to Java and not just related to this IDE. It's related to all languages, and it is a problem. So let's see if I can explain the problem. Okay. Somebody somewhere is going to want to use this to set a scene, so they're going to need a floor. Okay, and the floor is going to have some certain dimensions. Now, because we are human, our dimensions are probably going to be in meters. Why does that present as a problem? Because when we program this, we are going to have in the back of our mind that 1 meter equals 1.0 F. 1 meter equals 1 float. Okay. 1 meter 10 centimeters. Let's start looking at this. 1 meter 10. No, make it 11. 15 centimeters. That'll do. Centimeters is equal to 1.15 F. Come on, Muppet, move. You're on the keyboard again. Come on. The next question is, after you've done that, is what is 1 centimetre 15 millimetres? Well, it's 1.15 centimetres, isn't it? Yeah. Thank you, Muppet. It's equal to 0.0115. Can you see the problem? There's a gap between each millimetre, and that's why people fall through floors, because it's only accurate down to the millimetre. A millimetre is a big gap, and if you position your avatar within a game as a player exactly on that gap, by calculation, a calculation comes out to 0.01155, you'll fall through the floor if you count it, because you're only accurate to 4 decimal places. So when you do your calculations for movement and moving around this avatar around the world and interacting with the world, you will have to do calculations which take that into account. And you will have to restrict your calculations to only be able to give out 4 decimal places. If you give out any more decimal places than that, with splat straight to the floor. And that degree of granularity of millimeters. So the granularity of this program is millimeters. The best it can do is millimeters. But you might just turn around and say, well, why don't you call 1 centimetre 1? Quite easy. You will be dealing with numbers that are astronomical very, very quickly. If you are dealing in meters and you're already looking at 100 metre by 100 metre square, maybe a kilometre, in my case, I'm looking at a kilometre by a kilometre square maps. So that's 1,000. And then you want me to calculate in the tens of thousands? No. Now the banks know how to do this, and I know how to do this. How to get around this floating point error, which is lucky. The only thing is I'm not allowed to tell anybody, so, well, there you go. So, any questions? I think I'm well into question time here. Yeah, we're over the 3-hour mark. Good God. We did all the tests I wanted to do. It proved what I wanted it to prove, that everything isn't all fun and dandy in the house of programming, that there are big problems. And we are going to have to take those into account. All of these gets, all of these return functions should specify only to 4 decimal places. We should put into the specification that vector2f.java should be 4 decimal places. And that's why I'm not using somebody else's library. Because that I know they have not done. There is no way on earth that you will get hold of a library and it will say this library is safe to 4 decimal places. I doubt if you'll get any maths library advertising how many decimal places it is safe to. Let's have a look. How accurate is floating point maths using JOML? Is it a jar? All timing results to the 4th digit accuracy. So they know. Removal of decimal floats are supported, right? But with the notable exception and other packages. Okay, JOML's noted in there. All right. So it doesn't really seem to tell us. Okay. Okay, let's see what this one says. This is one of the problems I'm trying to get to. This is awkward. Use radians instead of degrees. This is something that you should look into, especially before or during doing any kind of a 3D engine. A 3D engine relies very heavily on this kind of thing, and you really need to be aware of it, totally aware of it, and all of these maths problems. It's not going to tell us, is it? Put jar in first. Jar, that's library. Vector arithmetic, blah de blah de blah. It's got a matrix API, good. It's got a vector API. Post multiplication. Come on, where's your floating point? Where's your floating point? Why aren't you telling us? Nope, no mention of it. It says about transferring them. No. Look at that. Full page. I've gone through the whole page, not one mention of floating point accuracy that I could see. And the cat's in the way a little bit. Oh, damn it. And it's not just this library. It's all libraries are like this. They just seem to ignore it. And when I go to test these libraries, I get the same results virtually all the time. Oh, I give up on that. So, I now have a week to think about it. Do we continue in Java, or can I find something better? Continue in Java. They are thought about it. Why not? To heck with it. It's all a learning experience and it's all a bit of fun, but today I hope I've proved to you the value of testing and things that you would not have known had you not tested. Or you can just type out what I've typed there. Oh yes, for the other ones. I don't know if it's obvious or not, so I'm just going to make some space. So if I was to copy these two, would it be obvious if I were to say add, well, call these subtract, SUB, and I was going to put a subtract and minus sign there, and a minus sign there, and guess what? A minus sign there, and a minus sign there. Would you believe me if I carried on and did that again? So I said, oh, instead of subtract, let's do multiplication. And for multiplication, I'm going to put a star there. I'm going to put a star there. You should test all these, by the way. You should still write the tests. Star there. And try and catch the tests out. Star there. Try and break them. Would you believe it if I said Control V and you put div there for divide? Div there for divide. And you went around all of these, and if anybody ever uses divide, they're a complete and utter muppet. So I'll put it in for the Muppets. There we go. I'll probably use it. I'm a Muppet. Oh no. My cat's called Muppet. So to me it's not a nasty, horrible term. It's a lovely, cuddly term. Oh, right. So that's all the basic math functions done anyway. Okay. Java. Vector2f. Have we completed it? Yeah, I think we have. Anything else I can think of in my notes? Oh, God. Yes. Yeah, alright. I did something silly, didn't I? Where did I put it? In window. The key code. Test initialization. Okay. This. Vec2 to string. Right, let's take you out. You don't belong here. You can go. And in here, right at the bottom, I suppose. I don't know. Any way you want to put it. We'll pop you here. And we'll just pop you out to that. It's not that anymore, is it? We're in vector2f. So it's just toString. And what we return is what it says. Okay, so we will have used that somewhere. I hope. But it isn't showing up here. So we've got a red line somewhere. No. 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 That's got to go. That's no longer there. And I don't think we're using it. It was a way to click and show where it was on the screen, but I took it all out. It was in ding game. Our game file. Why have we got a game file inside an engine? Well, we'll find out. Okay. Because you can't write a game engine without a game. Alright. I think we've got enough of those. I think hopefully I've hit home with that. Its importance. So next week, we'll carry on. We'll make our other bits and pieces, like maths library bits and pieces, and we'll just carry on. I might be going through testing on those, but probably not on air as it would be. So in the meantime, have a great weekend. Hey, I'm sailing tomorrow. It's Sunday, 2 p.m. And on Monday, I'm in hospital. Big sorry. I have to go into hospital. I don't know if I will be videoing, but I will be on Wednesday. So Wednesday, 2 o'clock, is the programming club, and that's just C++. So hope to catch you around, and I hope you have fun, and take care.